Hi, friends. How are we tonight? I'm 100% Cat, the cat that you've known and loved for 106 episodes. So, that's a fun fact.
Yeah.
Yeah.
Definitely. I don't know why you felt like you had to point it out, but I agree.
I just feel like if it wasn't me, I would be acting weird about it. So.
And that's not what's happening now.
Right.
So.
Yeah, it's fine. Whatever. We're doing the Ghouls. We do the Ghouls all the time. And I'm here to talk to you about parallel universes. The thing, we don't know if it's real.
Yeah.
We don't know.
Yeah.
Do they exist? That's the question we want to answer.
I don't know.
And before I get into my section, I would like to thank the physicist, Brian Greene. You don't know him probably unless you're really into physics.
I know a Brian Greene, but it's not this one.
I was not really into physics before this episode. I'm not either now, but I just want to say that I learned a little bit.
That's
I'm
good.
going to relay that to you. So Brian Greene said,
yes,
on an NPR special, it was Fresh Air, which I remember I used to listen to with my grandpa when I was
gross,
in the car, and also with our friend Will. But on Fresh Air,
they always talk titled, like this.
Yeah, really breathy.
Yeah,
just pleasant.
This is what news is.
Air.
Yeah.
Air,
It's fresh.
It's fresh.
It's just like where you get here at the Ghouls. Fresh air.
You're welcome. So it's called A Physicist Explains Why Parallel Universes May Exist. Really just says concise. Everything that I'm going to say. So Brian, my main man.
Yes.
Says in a way that 9 hours of a workday cat can understand. He said words. It was the first thing I had read where I was like, oh, okay, that is easy to read. Yeah. That is not an entire article of science words
and numbers
thrown at me that make no sense to me after a 9-hour workday.
Yeah.
This guy just told it how it was, super easy, and you're welcome. So he says, our universe might be really, really big, but finite, or it might be infinitely big. Both cases are possible. But if the latter is true, as in that they're infinitely big, so is this. There are only so many ways that matter can arrange itself within an infinite universe. Eventually, matter has to repeat itself and arrange itself in similar ways. So if the universe is infinitely large, it is also home to infinite parallel universes.
Makes sense.
So kind of like in our last episode, where it was it's possible, maybe. We can't say it's yes or it's no.
Yeah.
This, they actually, have ways to test if it's possible or not. It's just kind of really complicated. Really complicated.
Yeah.
And there's a lot of
I know
things.
You're my cat because he stumbles over words.
Yeah, you're welcome. This is my evidence.
This is like that theory where they're like, if you put 100 monkeys in a room with a typewriter over a million timelines or whatever, that eventually they'll write a Shakespeare tragedy, I think. It was the odds are that at some point they'll all the words that were used would end up in the same sequence. If there's an infinite amount of possibilities, then that could happen.
No, that checks out.
Is what I think.
I'm gonna say yeah. So basically, the idea is if it's finite, then we don't have multiple parallel universes because the universe can stop at some point, potentially reverse.
Mm-hmm. Big crunch.
Yeah, the big crunch. Then you have the idea where it's inflation is a thing, so it's expanding at a certain rate. It reaches a plateau where it calms down for a minute, which is where we are now.
Yeah.
And then we'll hit a point where it rapidly goes expands, or I guess
deflates.
I guess you
crunches.
Right? Or inflate. That makes more sense. Where it rapidly inflates again.
Or deflates.
Yeah, that's what I was thinking, but that might not be right. I think what you said was right.
Gotcha.
So basically, if there the universe is infinite. There's infinite possibilities and universes and versions of ourselves having varying differences that could be minimal or very largely impactful upon us. Reality is a little more interesting in that scenario because it's like, yeah, it's likely that we're never going to interact with that other version of us.
Yeah.
But we don't know. Like,
yeah.
There's a possibility that an event could trigger such an action of universes interacting with each other according to science.
Like the Mandela effect.
Yeah.
I'm in the wrong timeline.
Oops.
It's the worst timeline.
Yeah, and then like your boyfriend who loved you doesn't love you anymore, and it's sad.
Okay,
so,
I guess this isn't the worst.
Yeah, right. We have nice ones. That's fine. We didn't.
we didn't get these ones. We didn't murder the bad version of us, so we can have the good boyfriends. Yeah.
We murdered nice version of us to get nice boyfriends.
No. Okay, keep going.
Okay. So this idea is that they won't touch each other. Instead, they just exist parallel to each other. And he also explains that, like, in the fact that they would be infinitely expanding, if you take, like, that there is only a certain amount of matter that can exist within that space, like types of matter. So essentially, if it's finite and there's other ones that exist outside of it, the matter that they have could be completely different because it's not touching ours. But if the idea is that it's infinite, it goes on forever, there's only, and the laws of physics as they are in this universe exist as they do, that it would have to create copies. And like, so he uses an example of a deck of cards where if you had one deck of cards and that was all the matter that you could use in the universe, and you had to shuffle them into various patterns to get whatever you're going to get for the universe, eventually the amount of times that you do that, you would get one that was the same as one before.
Yeah.
Or maybe with
similar,
one card
different, yeah.
Slightly different. Yeah. Which is one decision that was made an opposite way.
Yeah.
Or a coin flip. Yes instead of no. I don't know. So it's interesting how this develops, because if you think about that and we add in math and science, I'm trying to like mush it all together. A lot of the theories around like quantum mechanics and the theory of relativity or something like that. I'm pretty sure that's what it is. They right. Contradict with each other. So essentially the theory of quantum physics is about things that are really small. Because quantum is talking about like the atom, and atoms are small.
Mm-hmm.
Quantum mechanics deals with small things and totally makes sense in describing how small things operate. Where like the other one is about big things and is basically Einstein and Apple. I'm not a scientist. We say this every episode. I'm a historian. So the idea is there's like many possibilities to whether your universe can exist.
Yeah.
There's the idea, so if we had infinite universes, we have bubble universes. I got this from space.com, which I thought was a fun
that seems real.
Website, which is basically the theory of multiple universes that come to internal inflation. So based on research from Tufts University cosmetologist Alexander Willington, when looking at space-time as a whole, some areas of space stop inflating, like the Big Bang inflated our own universe, while others keep getting larger. So if we were to picture a universe as a bubble, it's sitting in a network of bubble universes in space. What's interesting about the theory is that the universes would have different laws of physics. That was the one I was describing. So they exist separate from each other. So the rules within them, that's kind of like Rick and Morty.
Yeah.
Where when he goes to a different universe, like everything's all wacky.
Yeah.
They're like squid people now.
Yeah.
It's like, what? Or like there's like not even really even there, and there's just a lot of other stuff happening. So it's like there's still maybe somewhat similarities, but the laws that define how can exist are totally different in that theory. There's daughter universes, which I thought was really interesting because I feel like that's what we see a lot, even though that's not necessarily what we hear it coined as.
Mm-hmm.
It's basically multiple universes can follow the theory of quantum mechanics, how subatomic particles behave, as part of the daughter universe theory. If you follow the laws of probability, it suggests that for every outcome that you come up from one of your decisions, there would be a range of universes, each of which saw an outcome for another version of that. So it's like every time you make a choice, Mr. Nobody.
You see.
You get to see what would have happened under that specific choice. And then that would create a whole new universe for every decision that has ever existed. And basically, one universe, you got that job that you wanted, you took it. The other one, you decided not to go.
Mm-hmm.
You just both exist and you see what life happens now.
Yeah.
There's mathematical universes, which is basically whichever one you reside in, the structure is something you can describe in a way that's completely independent of human baggage, which is a theory made by Max Tegmark, Massachusetts Institute of Technology. He basically believes that there is a universe out there that can exist independently of me and would continue to exist even if there were no humans. So, kind of just plucks us out of the whole equation.
We don't even matter.
We don't matter now, anyway.
Yeah, that's true.
And then parallel universes is actually a little bit more complicated, where it's essentially, from what I understand of it, is that we exist, it kind of ties into string theory, where there are two-dimensional disks that are all kind of tied together in this plane. And they are able to, they're like the same but slightly different, is the understanding. It's like those are the different universes that can exist. And then it kind of, because of the particle configurations, the multiple universes would be limited to math numbers of a certain amount of distinct possibilities. So we'd be able to like measure exactly what could exist out there. And that some are the exact same as us, some of them aren't, you know, but the idea is that they would be similar to us, or just us a bunch of times.
Yeah.
Is kind of what I got. And then I guess what we'll see a lot in the films is this idea of Schrodinger's cat.
Yeah.
So it's a really complicated thing. I don't know if we have time.
No, go ahead, yeah.
Yeah, cool. So I'm going to give you a real nice, easy explanation of Schrodinger's cat. So essentially, this is something that went into quantum mechanics that was a way of understanding things, but the guy who made it, Schrodinger, presented this as like a total hypothetical scenario as a way to be like, it is so ridiculous that you think this thing could happen, which is specifically, it's a theory made by the Copenhagen interpretation, which essentially is explaining, it's all very complicated. I'm just going to read it to you and then it'll make sense, because it's called, the article that I read, A Simple Explanation of Schrodinger's Cat, the simplest that exists, the most simple. And I was like, thank God.
Yeah.
Because a lot of this is confusing and I don't understand. So it was from astronomate.com.
Nice.
And I'm very thankful for this article, because otherwise I would not know.
I'm learning so much already.
So Schrodinger's cat experiment is basically a thought experiment, something you can't ever test. It's just like, woo, what if?
Yeah.
We don't actually get to do it. We just get to imagine it, and it's fun.
Yeah.
In fact, we learned later, the team that like kind of thought it up, learned later, it's truly impossible to physically conduct Schrodinger's cat experiment, even if we wanted to. So you can't. It's forever just hypothetical.
Yeah.
So during the 1920s and 30s, a new scientific revolution was occurring. We realized an entire new realm existed in the smallest possible levels, quantum, so like the atom, and that the study of those things is quantum physics. So Austrian physicist Erwin Schrödinger. Erwin, I can read. Cat can read.
You can't.
So the idea of the experiment, this is what happens. First, a cat is placed inside a sealed box for 1 hour. Also inside the box are a container of radioactive material, a Geiger counter, which is the thing that detects radioactive particles, a hammer, and a container of deadly cyanide. Using the correct radioactive material allows a precisely 50-50 chance that within 1 hour, a single radioactive particle will be emitted. Basically, nothing about matter is certain until we observe it. That's what the Copenhagen interpretation says. So this process is known as I just said that, Copenhagen interpretation of quantum physics. In other words, it's simply looking at matter changes what it is. It changes what happens to it. It's kind of like the whole, like, so how I interpreted it is that, like, if I didn't tell you the vase was there, would you have knocked it over?
Yeah.
Matter changes because we look at it. Our presence in this viewing of matter will change what happens.
Yeah.
Or what would have happened.
Yeah.
So, what does that mean? Why does this matter? They give us 3 bullet points easily explaining that. After 1 hour in the experiment box, Schrodinger's cat stands a 50-50 chance of being dead and a 50-50 chance of being alive. But while the cat's in the box, it is both dead and alive simultaneously, according to
because we haven't looked at it.
Because we haven't looked at it. We have not looked at it and changed the matter within. Schrodinger's cat experiment was hypothetically used to show Schrodinger's disagreement with the Copenhagen interpretation for larger objects like a cat. So it's, if you're arguing, so remember I was saying quantum physics and the theory of relativity?
Yeah.
I'll find it one day. Look it up. There's a whole video.
Yeah.
Websites do it. But it was basically like some apply totally to small things. So like quantum physics totally makes sense for quantum physics.
Yeah.
But if you apply it to anything larger than quantum land,
like level, then
it doesn't work. Like you can't,
out. Yeah.
It doesn't check out for big things. So like,
so it's really funny because it's one of those things that like pop culture, just like modern thinking, like is wrong because he did it as a joke. Or not a joke, like it's not what it is. And so people take it to reinforce what Copenhagen said, but it just not. So that's funny.
Yeah, he was just like, it's so ridiculous. Why would you think that?
The cat is not alive and dead.
It can't be. Like,
it can't be both.
It can't be both.
But then it can't.
So, yeah. So I guess it goes on to, like, influence the theory that, like, parallel universes or daughter universes exist where there's a version of you that is split by the decision of opening the box versus not.
It seems unrealistic.
And here we are.
That's what he's saying. I gotcha.
So, what does this all mean? Do parallel universes exist? Lots of people think yeah. Some people think no. But the biggest thing is that right now, we don't know.
Yeah.
And the only way we're going to figure it out, so there is an experiment that exists for it where you can get a very large thing that makes particles smash together, which is interesting. And we basically would have to measure the time that existed within the particles smashing together and how much energy was taken from that time. And if we did that, it would confirm the idea of string theory that we are all like kind of in these parallel universes because the matter would bounce out into space outside of the universes, suggesting that we are in this row. If you want to understand that, I think if you listen to the NPR podcast, it would maybe tell you. But apparently we have the ability to figure it out. I don't understand it at all.
Don't put a cat in a box.
Yes. Don't put me in a box. That's the whole experiment. I will escape and I will destroy everything.
Just like a cat would.
Right?